Study Session 2, Methods of Inquiry. Introduction. In this study session, you will be exposed to the various methods of inquiry people use to acquire knowledge about behavior. The methods explained in this study session include the method of authority, the rational method, and the scientific method. At the end of this study session, you should be able to point out ways to acquire knowledge about behavior. 2. Differentiate the available methods of acquiring knowledge about behavior. Before a scientist can offer valid and general explanations for behavior, he or she must gather information about the behavior of interest. Knowledge about behavior can be acquired by several methods, including the method of authority, the rational method, and the scientific method. The method of authority. When you use expert sources, whether books or people, you are using the method of authority. This method involves consulting some source you consider authoritative on the issue in question. For example, consulting books, television, religious leaders, or scientists. This method was useful in the early stages of acquiring knowledge. However, it does not always provide valid answers to questions about behavior for at least 2 reasons. First, the source you consult may not be truly authoritative. Second, sources are often biased by a particular point of view. For instance, a psychologist may offer you a different explanation of an abnormal behavior from one offered by a behaviorally oriented clinical psychologist. For these aforementioned reasons, the method of authority by itself is not adequate for producing reliable explanations, although this is not to say that the method of authority is totally faulty in the search for explanations of behavior. The method does play an important role in the acquisition of scientific knowledge. This is because information you obtain from authorities on a topic can familiarize you with the problem in question, the available evidence, and the proposed explanations. With this information, you could generate new ideas about causes of behavior. However, these ideas must then be subjected to rigorous scientific scrutiny rather than being accepted at face value. The rational method. The rational method of inquiry takes place when you acquire knowledge about behavior through logical reasoning rather than authority or the evidence of one's senses. Knowledge acquired in this way must be approached with caution. The power of the rational method lies in logically deduced conclusions from self-evident truths. Unfortunately, precious few self-evident truths can serve as assumptions in a logical system. However, because of the shortcomings of the rational method, it is not used to develop scientific explanations, though it still plays an important role in science. The tentative ideas that you form about the relationship between variables are often deduced from logical reasoning. For example, having learned that fleeing from a fire or trying to get into a crowded arena causes irrational behavior, one can deduce that perceived availability of reinforces, that is, escaping death or getting a front row seat, is responsible for such behavior. Rather than accepting such a deduction as correct, however, the scientists put the deduction to empirical tests. The scientific method. According to Braithwaite, 1953, the function of a science is to establish general laws covering the behavior of the empirical events with which the science in question is concerned. He further argued that a science should allow us to fuse together information concerning separately occurring events and to make reliable predictions about future unknown events. One goal of psychology is to establish general laws of behavior that help to explain and predict behavioral events that occur in a variety of situations. Although explanations for behavior and general laws cannot be adequately formulated by relying solely on authoritative sources and using deductive reasoning, these methods, when combined with other features, form the basis for the most powerful approach to knowledge yet developed, the scientific method. The scientific method comprises a series of 4 cyclical steps that you can repeatedly execute as you pursue the solution to a scientific problem. Yarenke, Harari, and Lin, 1982. These steps are: observing a phenomenon, B, formulating tentative explanations or statements of cause and effect, C, further observing or experimenting or both to rule out alternative explanations, and D, refining and retesting the explanations. Observing a phenomenon. To observe the behavior of interest is a starting point for using the scientific method. At this stage, some behaviors or events may catch your attention. These preliminary observations of behavior and of potential causes for that behavior can take a variety of forms. Through the process of observation, you identify variables that appear to have an important influence on behavior. A variable is any characteristic or quantity that can take on 2 or more values. In the example cited in the last study session, the amount of violence in a war film is a variable that can vary from very low to very high. Don't forget that in order for something to be considered a variable, it must be capable of taking in at least 2 values. Any characteristic or quantity that takes on only 1 value is known as a constant. Formulating tentative explanations. After identifying an interesting phenomenon to study, next step is to develop 1 or more tentative explanations that seem consistent with your observations. This means that you tentatively state the nature of the relationship between 2 or more variables. That is, the relationship between variables that you expect to uncover with your research. The tentative statement you offer concerning the relationship between your variables of interest is called a hypothesis. This stated hypothesis must be testable with empirical research. For example, a child is more likely to be aggressive after watching a war film than after watching a non-war film. Notice that the hypothesis links 2 variables, the war film and the aggressive behavior, by a statement indicating the expected relationship between them. In this case, the relationship expected is that watching war film will increase the likelihood of behaving aggressive by a child. Research hypotheses often take the form of a statement of how changes in the value of one variable, that is, watching war film or non-war film, will affect the value of the other variable, aggressive behavior. Further observing and experimenting. Up to the point of developing a hypothesis, the scientific method does not differ markedly from other methods of acquiring knowledge. At this point, all you have done is to identify a problem to study and develop a hypothesis based on some initial observation. The scientific method, however, does not stop here. The third step in the scientific method marks the point at which the scientific method differs from other methods of inquiry. Unlike the other methods of inquiry, the scientific method demands that further observations be carried out to test the validity of any hypothesis you develop. Making further observations is simply what the scientific method is all about. After formulating your hypothesis, you design a research study to test the relationship you proposed. In this case, you decide to design an experiment in which you systematically manipulate the amount of violence in a war film and observe whether different levels of violence in the film produce different rates of aggressive behavior. Refining and retesting explanations. The final step in the scientific method is the process of refinement and retesting. For example, imagine that you found that war film increases aggressive behavior. Having observed this result, you would probably want to explore the phenomenon further. Will the realism of a film matter? A refined hypothesis might take the following form. Realistic war films are more likely to result in increased aggression than unrealistic war films. This process of generating new, more specific hypotheses in the light of previous results illustrates the refinement process. Often, confirming a hypothesis with a research study leads to other hypotheses that expand on the relationships discovered. Explore the limits of the phenomenon under study, or explore the causes of the relationship observed. As you become more familiar with the process of conducting research, you will find that not all research studies produce affirmative results. That is, sometimes your research does not confirm your hypothesis. What do you do then? In some cases, you might completely discard your original hypothesis. In other cases, however, you might revise and retest your hypothesis. In the latter instance, you are using a strategy known as retesting. Keep in mind that any revised or refined hypothesis must be tested as rigorously as the original hypothesis. Study session summary. There are ways to acquire knowledge about behavior. These include method of authority, that is, acquiring information from sources that you perceive to be experts on the topic of interest. With rational method, you deduce explanations from other sources of information. This method of authority and rational method, though play important roles in early stages of science, they are not acceptable methods for acquiring scientific knowledge. The scientific method is the only method accepted for acquisition of scientific knowledge. The four major steps of the scientific method are observation of a phenomenon, formation of tentative explanations, further observation or experimentation to rule out alternative explanations or both, and retesting and refinement of the explanations. End of study session 2. Thank you for listening.